Hello students, welcome back. In this video, we're going to introduce the core mechanic of our game, our radioactive reactor cells that the player can push around the arena and push into our containment ports to essentially save the day, prevent a nuclear meltdown. This is going to require us to look at collisions for the first time here in our game. And for the shape of our player and our reactor cells, both being rectangles, we'll look at rectangular collisions here in this video. So let's dive to the computer screen and head right in. I have lesson 3's starter file open here in vscode.dev. I'm going to minimize my browser and open that file directly in the browser as well. So here is my core file folder, lesson number 3, and we'll open up our starter file. So if I hit enter, you can see here it's pretty much the same state that we were at. I have my overlay screens. I can do a game over and a restart. But now we've got some more text here in our HUD. It says cells contained. And it's just keeping it at 0. So right now, no cells are spawning in the arena, none of our reactor cells. We can't interact with them. We can't score them. So we got quite a bit of work that we have to do here in lesson number 3. So let's head right to it. So I'm going to start here by just looking at our mission checklist. Mission number 1 asks us to spawn multiple reactor cells into the chamber. Eventually, we'll have a system that spawns cells for us in given time intervals. But for right now, that system's not in place. So we're just going to manually spawn some cells. So let's see where we want to do this. I'm going to hit Control F to open up my search bar, and I'll type mission 1. And it looks like we are going to be doing this in our reset game to defaults function. So anytime we restart our game, we need to spawn some cells. How are we going to do that? Well, in particular, we're told we want to create 3 cells at the start of our game. So let's just go explore our code here for a second and see what type of functionality we might have. So we've got update player, get input direction. Okay, and now if you look here, we've got a function called generate cell data. Then we have a function called spawn cell, and we have a function called check player cell collisions. I think these 3 functions are going to work in unison to build our cell system, the core mechanic of our game. We are going to generate our data and then spawn that data and then check to see if we have a collision. So first off, let's look at the generate cell data function. It's returning something to us. It's returning an object that has 2 properties, an X property and a Y property. And the X and Y properties are randomly picked for us. We're calling the random function to randomly select a value from 20 all the way to like the width of our window. So the width all the way over here minus the cell's size minus like another 20 is like maybe like a buffer. And then we're doing something similar in the Y direction. So it looks like our cell data is just the X position of the cell and the Y position of our cell, which is going to be randomized. We also have a function called spawn cell, and it looks like inside of here we're calling that generate cell data function. Remember, this function returns something to us, so right here we're getting that object. So this object right here is being placed right inside of these parentheses. And what are we doing with that object? Well, it looks like it's cells.push, and then we're pushing that object into this variable cells. So we got to do a little bit of understanding what cells is. So if I scroll up to the top of my program, we have some gameplay variables that are introduced here in this lesson. First, we have something called an array named cells. An array is defined as these square brackets. You can think of this like a container with which you can put a bunch of stuff. So maybe I'm going to create like 3 cells, and I'll call them cell 1, cell 2, cell 3. I can put all of those cells inside of this array or inside of this container. And so when I want to do operations on every single cell, instead of referencing cell 1, then cell 2, then cell 3, I can just reference the array by its variable name. I can reference the container, and I can say, for every item that is inside of this container, do the following. And that's a really powerful tool that we have with arrays. This is called for loop iteration, and we'll look at some examples of that here coming up. We also got a variable called cells contained, which is equal to 0. And if you look, I think that's probably what's showing here in our HUD. Okay, so we've got this array cells, and right now there's nothing in it. And so if I go back to our spawn cells function, it looks like we're taking that array and we're calling push on it. What this does is it takes something and puts it at the end of this array. So we're getting our cell data, which is an object, the x and y coordinate of our cell, and we're pushing it to the end of the array. So right now, if the array is empty and we created a cell, I'll just call it cell 1, we'd put it at the end. If our array had one cell in it and then we created another cell and we pushed it to the end, it would go right here, cell 2, and then cell 3, and so forth and so forth. All right, so it looks like we got to call this spawn cell function to fill our array or container with cell objects. So I'm going to go back up to mission number 1, and I'm just going to call this function 3 times. Spawn cell. All right, so there's our first time. Spawn cell. So now we just pushed a second cell into the array, and then I'll call spawn cell. Hey, we just pushed a third cell into the array. Let's refresh this page and let's see if we see these cells. Oh, ladies and gentlemen, I don't know about you, but I see 0 cells on the screen. What a bummer. Well, here's the thing. We are defining the data. We just defined the data, right? We spawned our cell, and if we look, we generated our cell data. We defined the data for the first cell and pushed it into the array. We defined the data for the second cell and pushed it into the array. We defined the data for the third cell and we pushed it into the array. But remember, there are 3 things that we have to do. We have to define the data, update the data, and draw the data. And right now, all we've done is define the data. So let's look at mission number 2. Mission number 2 says, hey, now that the data is defined, you have to draw that data. We got to draw our cells. We're going to draw the reactor cells inside of our chamber, inside of our world, and we're going to display each cell as a visible object. So this is inside a function called draw cells. So this is our drawing. And so if I scroll up a little bit, in draw scene, we draw everything in regard to our game. The background, the goals, now the cells, the player, the HUD, and our overlays if certain conditions are met to be true. So inside of draw cells, let's look at what we have here. So it says no stroke. Remember, that means give me a marker that is invisible so you don't see the outline of the shape that I'm about to draw. And then we put some paint in our paint bucket. We have a color called cell safe color. Now we've got something brand new here. This is called a for loop. Remember, we said an array or a container is super special because it allows us to loop over and do operations for every single thing inside of the container, right? We might say, hey, for every cell inside of this container, I want you to draw that cell. And that's exactly what we're doing here. We're saying for a const called cell of our array cells. This is our container, and this is what is inside of our container. So inside of our container, if I just say, okay, imagine here is my array, cells. I have cell 1, then cell 2, then cell 3. The first time this for loop runs, this variable cell is our first cell. The next time the for loop runs, this variable cell references the second cell, and the third time this variable runs, our variable cell represents the third cell. So it continually moves or iterates through this array. And I will just say one last thing about arrays. They have positions. Now here's where it gets a little wacky. This first element is at position 0. This second element is at position 1. And this third element is at position 2. We start indexing or counting positions of an array at 0. That will come in handy later, but not right now. We don't necessarily need it. So we're going to loop through our array of cells, and what do I want to do? Well, I want to just draw a rectangle. So I'm going to say, okay, rect, the rect function. Now, if you remember, the rect function needs 4 pieces of information. It needs the top left corner, so the x coordinate and the y coordinate of the top left corner. I mean, I guess I could do, I don't know, 0, 0. And then we need the size of the cell. I don't know, maybe I'll do like 50 and 50. I have no idea. Let's just see how this works. Let's refresh the page. Hey, look at that. We kind of got a cell. Like, way up in the corner at 0, 0, and its size is 50. I mean, it sort of works. What if I change this to like 100 and 100? Oh, I got to move outside of my cursor. Let's refresh the page. Hey, there's my cell. Look at that. I got a reactor cell, 100 and 100. But that's not really what I want. First off, it's way too big. I got to have a better variable for its size. In fact, I think if I go up to our constants, our student edit zone where we define our data, if I scroll down here, I have a variable called cell size that I can work with. It's set to be 25. Let's use that variable cell size for the width of the rectangle, so cell size, and for the height, cell size. Let's also round the corners. So we'll add one more piece of information to this function so we can round the corners of it to make it look just a little bit better. That looks nicer, and it's a pretty good size in relation to my player. But here's the problem. Right now I'm drawing all three of the cells right on top of each other. Okay, they're all there. We don't want that. If you remember, when we defined our cell data, we said, hey, our cell object is going to have, where is it? Here it is, generate cell data. It has an X property and a Y property that we randomly set. So we are going to use each individual cell's X property and Y property when we draw them. So right here, instead of hard coding 100, remember we have this for loop, for const cell of cells. This is the array. This is the individual cell that we are working on. So I'm going to say, hey, that individual cell has an X property. And that individual cell has a Y property. And so now when we run the game, we should see not one, not two, but three cells all randomly drawn within our arena. And there they have it, 1, 2, and 3. If I restart the game, I get them moved. I restart. They are continually moving and are nice and random. So this is working perfect. Mission 1 is complete. Our mission 1 and mission 2 are complete. We defined our data. We drew our data. What do we now need to do? Next, it says, well, we should be able to detect whether or not a collision has occurred between a player and the cell. So right now, right, if I go right here, I should begin to be able to push this cell. Right now, we're not detecting any collisions. I'm just sort of moving right over them. So in order to figure this out a little bit better, I think what we're going to do is we're going to bring up a whiteboard here. Okay, so we have the whiteboard up, and let's actually draw a picture and talk about how can we tell if a collision has occurred between our player and our cell. So I'm going to start by drawing out the player. So here is my player. Zoop. Okay, so there's my player. And then I'm going to draw out my cell. So maybe here is a cell that I want to collide with. And so we're going to highlight some important points. First, we're just going to look in the horizontal direction. So remember, the X value of our rectangle is defined as the left side. So this is P, we'll say P dot X, our player's X coordinate. And then all the way over here is that X coordinate, which we're keeping track of, plus the player's size. So I'll say plus P size. And then the same values can be true of our cell. Our cell has an X coordinate, which is going to define the left side. I'll call that like C dot X. That's its X property. And then this is its size. And so I'll say, okay, this is C dot X plus C size. Now, how do we know when a collision has occurred? Well, there's some conditions that have to hold true, right? So some conditions. If we think about it, as the player moves further and further to the right, eventually this point right here, P dot X plus P size, is got to go past this point of the cell, right? If that's happened, if this whole part moves over, then there's a chance we have a collision. A chance. Now, we're going to write that condition out by saying, okay, if P dot X plus the player's size, if that point right here, if its X value is further to the right or greater than C dot X, the left point of the cell, there's a chance we could collide. Of course, what if I put the cell like all the way over here, right? What if the cell was zoop, all the way over here? I mean, you can see that that point right here is greater than this point, but we don't have a collision. So what we also have to say is that at some point as we move, we have to make sure that this point, P dot x, is still smaller than the right point. And so we were going to say also P dot x must be smaller than C dot x plus C size, meaning the right end of the player has to be further along than the left end of the cell. That's this one. Check. And we'll also say the left end of the player has to be less than the right end of the cell. If we've done that, we have an overlap in the horizontal direction. The cell lives somewhere inside of here. Of course, there is another direction that we have to apply this logic to, and that is going to be the vertical direction. So now if we look, here's my player. Zoop, zoop. And I'll define this top part as its y property. And then if we zoom all the way down here, right here, this is going to be its y property plus p dot y plus p size. And let's imagine we've got some cell. So here's a cell, and we want to check if we are about to collide with it. Well, the cell has a y property, c dot y, and it's got a size. So this point right here is c dot y plus c size. In just like our earlier argument, if the player moves down, they move down, eventually this point is going to be greater than c dot y. So if this point right here, which is p dot y plus p size, if that point is greater than c dot y, there is a chance we have a collision. Of course, if I put the cell way up here, zoop, well, then you can see how that point is greater than this point. But we've gone too far, right? We've gone too far. So we also, just like we did here, we now have to check to see, is this point, the p dot y, is it less than that point right there? So we're going to say, hey, is p dot y less than c dot y plus c size? If both of those conditions are true, right, this is checking to see, is the bottom of the player past the top of the cell? And then this part is saying, is the top of the player still behind the bottom of the cell? If those things are true, then we have a collision in the vertical direction. Then that means our player and cell is somewhere, our cell is somewhere inside the player. But what we need is for this to be true, and this to be true, and this to be true, and this to be true. We need all four of them to be true. And if those things are true, then we have what is called a rectangular collision. All right, collision. We have it. We've done it. And that means we should be able to move the cell. So let's go back and apply this concept now to our program. So we have mission number 3. It says we got to detect collisions between the player and the cells. So mission number 3, we are in a function called check player cell collisions. Where is this thing even being called from? Well, if I scroll up to our draw function, if we're in the play mode, remember, this runs every single frame. If we're in the play mode, we're updating the player, and then we're checking our player cell collisions and checking our goal collisions, our cell goal collisions. So we're going to check to see if a cell has collided with the goal as well. And then, of course, we're drawing our scene. So this function gets called every single frame. And if we look, we're looping through all of our cells. So here's our array, 4 const cell of cells. So we're going to loop through cell 1, check cell 2, check cell 3. We're going to see if we're colliding with any of them. If we're asking a question, here's the first part of the question. If player.x plus player size is greater than cell.x. I believe that's what we have right here. So, okay. Then we have 2 ampersand signs. This is the logical and, meaning every single one of the parts of this question have to be true in order for the overall answer to be true. There's our other horizontal check. Then we have our first vertical check. Player.y plus player size is greater than cell.y. I believe that's this right here. So we just need this last vertical check. And look what we have instead. We have false. That's never going to evaluate to true. So we got to get rid of that and finish this rectangular collision check. So we'll say, hey, player.y, that's the top of the player, if it is less than cell.y plus our variable cell size. If that is the case, we have now completed the question. We have 4 conditions that need to be true. If that is the case, what do we want to do? So everything right in here is the question. That question, if it is true, what do we want to do? Mission 4 is where we are going to execute our code. Notice we've got curly brackets here to execute this code, meaning if that question were true, all of the code inside of these curly brackets is going to execute. So it says here for mission 4, we want to push the cells. Push the cells using the player movement direction. Move cells when the player walks into them. Okay. Well, remember we talked about, hey, that get input direction function, which returned, what was it? The key presses, right? Return here is get input direction. It returns dx and dy, which is a representation of what direction we are moving in. If we're moving to the left, dx is -1. If we're moving to the right, dx is +1. If we're not moving horizontally at all, dx is just going to stay 0. And a similar thing can be said for dy. So we're returning that object. We're going to use it down here in mission number 4. So we know if this question evaluates to true, we have a collision. So now we want to move our cell. We're going to update the cell's x position and y position, the x property and the y property. So I don't know. Let's just hard code these to 5, right? Let's just hard code cell x to 5. What's going to happen here? I have no idea what's going to happen. So if I collide, hey, it starts to move. So that looks pretty good. Of course, if I collide here, it moves to the right. If I collide this way, it moves to the right. It's always moving to the right with our collision. That's not really what I want. So we got to change that. Based on how the player is moving, we have to move the cell the correct way. We get the player's movement right here in this variable called move direction. So remember, move direction is going to be that object that has a dx and a dy. So I'm going to call move direction, that variable that we have, and we're going to access its dx property. So that's going to tell me, am I moving to the left or am I moving to the right? Or am I not moving at all in the x direction? And then we'll do something similar for move direction dot dy. All right, that's sort of going to work. Let's check it out. So can I move it to the right? It sort of moved. I don't know if you saw it. It's slowly moving to the right and to the left. And it's slowly moving up and down. But there's a problem. Our player is moving so much faster. Because if you remember, our player's speed, I believe, is 5. And we are moving dx and dy as either +1 or -1. See, this represents the direction of the speed. But what we then have to do is multiply by the size of the speed. And that is our variable player size, which we set, or not player size, I'm sorry, player speed. And player speed was set to 5. So now when we move our cells, they will move at the same speed as the player, the same size, speed, and the same direction. Let's run this. Let's see if we have good rectangular collisions. Hey, that works pretty good. That looks great. That worked great. And that worked awesome. So I'm very happy. Now we just need to be able to collide them with the goals. It also looks like, okay, so that sort of is working. Okay, we got a little bit we got to do to clean this up. Let's see if we can take a look. Let's go to mission. We just did mission number 4, so mission number 4 looks great. Let's do mission number 5. All right, mission number 5 is all about a goal collision. So if we look, we're going to do something similar here. We have for const goal of goals, and we've got a nested for loop. So for, ooh, look at this. Our for loop is defined differently here. It doesn't say for const cell of cells like it did before. And the reason why is, in this case, we are eventually going to remove a cell when we score a goal. We're going to get rid of it. And when we want to remove something from an array, we have to be really careful how we do that. Otherwise, if we're not careful, we could really mess our program up. I'll just say this. So we need to loop through the array backwards, meaning if this is my array and I have cell 1, cell 2, and cell 3, when I do for const cell of cells, I start here, I do my operations, then I do operations here, and then I do operations here. But for this connotation of a for loop, let I equal cells.length minus 1. Our length is 3, and we subtract 1 from that to get 2. Why do we do that? Well, remember, we start counting or indexing these at 0. So for a length of 3 minus 1, that gives me 2. So I is 2. We reach in and we grab inside of this array whatever is at position I. So that's going to be at position 2. So we start here at this cell. Then we go until I is, as long as I is greater than or equal to 0, and I minus minus means we subtract 1. So we start here, the next iteration, we go here, the next iteration, we go here, and then we stop. So we're essentially looping backwards through this array. We do this anytime we want to delete something out of our array. Now, if we look here inside of our for loop, for every cell that we have, we then are going to check every goal. And we're doing rectangular collisions again. So our rectangular collision logic is going to hold exactly the same. This time, instead of player and cell, we are going to do goal and cell. So we've got the first check here in the horizontal direction, our second check in the horizontal, our first check in the vertical, and now we need our last check in the vertical. So I'm going to do cell.y, so that's the top of the cell. If it is less than, let's do goal.y plus goal dot, what have we got? Height? Yep, goal has a height. How do I know goal has a height? Well, if I look all the way up in our reset games to default, I define, look at that, another array for my goals, and it holds all 4 of my goal objects. They have an X property, a Y property, a width, and a height. So we can access that height right here. All right, let's go back to mission 5 though, because if we are colliding a cell and a goal, what are we actually doing? So here's the question, right? Here's the question that we're asking. If that question is true, we're going to run all of this code inside of these curly brackets. And right now it looks like there's some missions in here, so we'll handle that. And it just says cells contained plus equals 1. Okay, so if we look, we're keeping track of how many cells are contained. It says 0. Let's see if that goes up. Nothing. It didn't go up at all. Well, that's a huge bummer. That should have gone up. Let's double check and see what is going on. Well, at a quick glance, it looks like we should be changing that variable, but it's not changing. I think I know what is happening. We are updating our data, right? So we can see this variable cells contained is getting updated, but we're not drawing the change of that data. So remember, there's 3 parts here that all have to play together. We got to define the data. We have to update the data. We have to draw the data. I think we defined the data. We defined what this variable was way back. Where did we define that data? Right there, cells contained. Let cells contain equals 0. Boom, we defined it. Then we are updating that data. Where are we updating it? Right here. We're adding 1 to it. But I don't think we're drawing it yet. So we got to hold off on that. We'll get to that. Let's move to mission 6. It says we should remove our cells. Remove the contained cells from the chamber. Delete a cell once it reaches the goal. So how do we delete a cell? Right now, if I restart my game, right now when it collides, boop, I got to score a goal. That cell should be gone. I don't have to worry about it exploding. So the way we remove something from an array. Remember, all of my cells live inside of this array called cells, right? So there's cell 1, there's cell 2, there's cell 3. The way we remove something from an array is using the splice method. So I'll do cells, the name of the array or the container, dot splice. Now, splice needs 2 pieces of information. Where in the array you want to start splicing or removing from. This is the position. So imagine, let me just undo this, right? So remember, this is position 0, position 1, and position 2. So we have to know what position of the array we are in. Thankfully, the way we defined our for loop, right up here, we have the position. Remember, our variable I was going to be 2, then 1, and then 0. We're looping backwards through the array, and we have the position. So we're going to use the splice method. I'll do cells.splice. At position, not 0, not 1, not 2, but position I. That is a variable that's going to change. And then we also got to put in how many we want to delete starting at this position. I only want to delete 1 starting at this position. If I had put 2, it would have deleted the one at this position and then the next one after it. We don't want that to happen. All right, so the splice method is working. It's operational. Let's see if I score a goal. Does did the cell disappear? Hey, look at that. I kicked it into the goal. It's gone. I kicked it into the goal. It's gone. I kick it into the goal, and it's gone. And now all of my cells are gone. That's so sad. So what we need to do is create a system that respawns the cells. So if you look here, that's mission number 7. Once we score a cell, we're going to spawn a brand new cell to keep the chamber active with new cells. We know how to spawn a cell. We have a function called spawn cell. We used it all the way back at the beginning of this video, if you remember. It will randomly generate a cell data with a random X and Y coordinate. And so then we'll create one, a brand new one. So we delete the old one and we create a new one. Let's see. Hey, look at that. It popped right up. It popped right up. Hey, this is kind of cool. So now every time we score a cell, right, we contain a radioactive cell, another one pops into the game. So I really like that. The last thing I really need to see before I feel good about this is I got to see the HUD updating, because we are updating our variable. Every time we score a goal, right, we contain a cell, we're increasing this value. We're updating our data. What we need to do is go to mission number 8. Mission number 8 puts us in our draw HUD function. I'm not surprised about that, because this is the glaring thing that we have to do here at the end. We have to draw our updated data. And mission 8 is all about the containment count. We are going to track and display the containment count, increase and show the number of cells that are contained. So if you look here, we're drawing our, what did we do? We drew our title, some move instructions, and then we changed the alignment to be right aligned and in the horizontal direction. And so the right end is going to be over here, right? So this 0, the 0 is what we're going to position in the X direction. So our X direction, we're saying take the width of the canvas and subtract 15 pixels. So if I get rid of that 15 and it's right aligned, the 0 is going to be all the way at the far end. And so you can see that right there. So by subtracting 15, we're essentially just putting like a little bit of padding on this, a little bit of extra space. But I don't want this to say cells contained 0. I want to actually use the variable that I have that is going to be updated. So I'm going to get rid of the 0 and I'm going to add to that string that we're displaying. So I'm going to have it say cells contained always, but then I'm going to add to that string whatever is inside of my variable cells contained. So it's going to start as 0 and then it should increment to 1, increment to 2, increment to 3, increment to 4. Keep going. So let's take it up. Let's check it out. Let's take a look. So now when I score a cell, I got the collisions going. That works nice. Boom. I got 1 point, 2 points, 3 points. Oh, I missed that one. 4 points, 5 points. This is working exceptionally well. I'm very happy with this. All right, so let's head back to the code here for a second. And I think we can wrap it up. We did all 8 of these missions exceptionally well. So now our core mechanic is in place. I think we kind of almost have a fully playable game. It's not too exciting. I mean, we spawn 3 cells into our game. They're not technically radioactive yet. There's no threat, no pressure. They just sit there unstable or stable. We have stable cells. We have to make them unstable somehow. Make it so that they could potentially erupt and leave radioactive waste all over the battlefield that could harm us as we play the game. And we'll continue building out that system in our next video. So I'll see you then.